Hello guys, in this video, we're gonna talk about and we will show you how to prove mathematical induction.
Let's get right into it! Let's define what is mathematical induction. Mathematical induction is a mathematical proof technique. It is essentially used to prove that a property holds for every natural number and so on.
Oh my god, this is so annoying. I really don't get anything and I've been staring at it for so long. Hey Jamie,
Yes.
can you help me out with this one?
Oh yes, I'll be glad to help you, but I think we should meet with Reese so you can understand it better.
Okay, sure.
So in proving a mathematical induction, the first step would be verification. So the problem is we need to prove that the summation of 2i minus 1 squared from I is equals to 1 up to n is equals to n times the quantity of 2n minus 1 times the quantity of 2n plus 1 all over 3 is true for all natural numbers. So in verification, we will start with n is equals to 1. We need to distribute the value of n to the given equation. So the equation would be like this. The quantity of 2 times 1 minus 1 squared is equals to 1 times the quantity of 2 times 1 minus 1 times the quantity of 2 times 1 plus 1 all over 3. When you solve this equation, it would be equal to 1 is equals to 1. The next one is n is equals to 2. So we all know that this is also an arithmetic series. So what we'll do is we will add this equation to the next equation that we will create. So the equation must be like this. The quantity of 2 times 1 minus 1 squared plus the quantity of 2 times 2 minus 1 squared is equals to 2 times the quantity of 2 times 2 minus 1 times the quantity of 2 times 2 plus 1 all over 3. When you solve this equation, this must be equal to 10 is equals to 10. There you go.
So the second step in proving mathematical induction is called Induction Hypothesis. In this step, you will just assume n is equals to k is true. So this will result to the quantity of 2k minus 1 raised to 2 is equals to k times to the quantity of 2k minus 1 times to the quantity of 2k plus 1 all over 3. So the third step in proving mathematical induction is called the POI or the proof of induction. So let's first solve this column. In this column, you will input the second term and you will add it to the first term with the k plus 1 on it. So this will be k times the quantity of 2k minus 1 times the quantity of 2k plus 1 all over 3 plus 2 times the quantity of k plus 1 minus 1 squared. So we can see that we are multiplying two binomials here. So we will do the FOIL method. First, outer, inner, and last. If you do that, this will result to 4k squared plus 2k minus 2k minus 1 all over 3. And on this side, we will just distribute the 2 to the quantity of k plus 1. So this will be 2k plus 2 minus 1 squared. So we all know that positive and negative contradicts each other. So positive 2k minus 2k is cancelled already. So this will result to distributing the k 4k cubed minus k all over 3 plus 2k 2 minus 1 2k plus 1 squared. Then we can see that this quantity is squared. 2k plus 1 squared. Therefore, it's a binomial. So if you expand this term, it will be equal to 2k plus 1 times the quantity of 2k plus 1. Then bring down this. Then after you use the FOIL method here, you will get the result of 4k squared plus 4k plus 1. And you will also bring down this. So we can see that there are dissimilar fractions because this all over 1 is all over 3. So you will multiply this by 3 and you will put over 3 here. So this will result to 12k squared 3 times 4, 12k 3 times 4, 3 times 1 all over 3. So now they have similar denominators. Then you can add this. This will equal to 4k3 minus k plus 12k squared plus 12k plus 3 all over 3. Then you will simplify, and this will be your final answer. 4k cubed plus 12k plus 11k plus 3 all over 3.
So in the second column of the proof of induction, we will use the second term. And the equation would be k plus 1 times the quantity of 2 times k plus 1 minus 1 times the quantity of 2 times k plus 1 plus 1 all over 3. First, you'll need to distribute this term to the quantity of k plus 1, which will result in this equation, which is k plus 1 times 2k plus 2 minus 1 times the quantity of 2k plus 2 plus 1 all over 3. The next thing you need to do is you'll solve these two terms, which will result to this. You'll just add the 2, you'll just minus 2 minus 1, and it will result to positive 1, and 2 plus 1 is equals to positive 3. The equation would be k plus 1 times the quantity of 2k plus 1 times the quantity of 2k plus 3 all over 3. As you can see, we're multiplying binomials here, and we can do the FOIL method. After doing the FOIL method, it will result to this. K plus 1 times the quantity of 4k squared plus 6k plus 2k plus 3. 6k and 2k are like terms, so we can combine it, and it would be 8k. The next thing is that you'll distribute this binomial to the quantity here. So it will be like this. K times 4k squared, k times 8k, k times 3. And you also do that to the positive 1. After doing that, it will result with this. 4k cubed plus 8k squared plus 3k plus 4k squared plus 8k plus 3 all over 3. What you'll do is that you'll combine like terms. After you combine like terms, you result with the final answer, which is 4k cubed plus 12k squared plus 11k plus 3 over 3. So as you can see, it is now both equal, and we prove that this equation is true for all natural numbers.
Thanks to my friends Reese and Jamie who taught me how to solve mathematical induction, I therefore conclude that the statement, the summation of 2i minus 1 raised to 2 from I is equals to 1 up to n is equals to n times the quantity of 2n minus 1 times 2n plus 1 over 3 is true for all natural numbers.
That's all for this video. Hope you learned something.
Bye-bye!